Okay, well, we're excited to start our webinar tonight. Thanks so much for everyone being here. It's always exciting for me to see the numbers go up with the room, people filling up, joining the webinar. It's always the exciting part as we get this thing kicked off. So just a quick reminder of where you are today. You're in the droidCon online webinar series. This is part one of what we're calling our hands-on and in-depth series. So a lot of practical knowledge that we want to get in your hands today. We're really grateful that we've been able to partner with Gradle on this presentation and have Nelson here with us today to present to you. Before we get to the rest of the lineup, want to do just a couple of quick housekeeping items before we turn Nelson loose on his presentation. So as you can see, we've got, if you've been with us before, you'll know that all of these webinars are recorded, so for posterity, so you'll be able to see these tomorrow or the next day on droidcon.com, and they will also be transcripted and fully searchable. So we're excited to make those available to you there. Just a quick item of business. What's up next? If you have been checking out the schedule, up next we've got a great up with Osacky and Martin, also part two of our hands-on and in-depth series. So go take a look over at online.droidcon.com. and you should be able to get a good idea of what's coming up next. But register for that because we think that's going to be a fantastic event coming up. For those of you who are joining for us the first time, you'll know that we do the Q&A over Slido. So take a quick run over in your browser to slido.com. You'll be asked to put in an individual code, and that's this particular code listed here, and that will get you to the particular event. You can also check in the chat function, and that will, in the chat function, you'll also have a link, a direct link. Jan should be sending that over, so make sure that you check in your chat function for that particular Slido link. And in fact, I am just going to verify that code one more time. Yeah, 62277, that's the one. So we're excited to have you do that. So basically, go over to slido.com. If you see that somebody's asked an important question, something that you wanted to ask, give it a thumbs up, vote for it. That way, the most important and most relevant questions slide to the top, and that in the limited time that we'll have to answer to questions that Nelson will have after his presentation, we'll get to the most important questions. So you guys see that Jan has sent that over in the link and the code as well. Today, just so you know, what we're doing, we've got Nelson Osacky here with us doing the presentation, not just another modularization talk, scaling Android build with Gradle. After he's done talking, stick with us because we've got an awesome panel discussion. As you can see, we're really happy to welcome with us Ivan Gavrilovich, Zach Swears, Israel Camacho, John Rodriguez. It doesn't get more experience than this in terms of lineup, talking about all things Android builds, performance, speed, features. So stack up your questions too. This is a really good opportunity for you guys out there to ask and get answers to all the questions that you've been wanting to know. So we are really excited to have them with us, and we'll be having them join the panel, join this just as soon as we've given Nelson a bit of time to do his Q&A. So that is it for me. What I'm going to do is now get out of the way, turn the time over to Nelson here, make him the presenter, and he'll be able to share his screen with you. So here we go. Nelson, if you can share your screen, I'm going to duck out on the video, so it's all you. And we look forward to your presentation.
Hey, thank you for the intro. It seems I need to enable some permissions here. So I will be right back in order to screen share.
Yeah, this is always the very exciting part of the webinar, especially doing something live. There's always the little gotchas that happen, but that's just part of the fun that we all have with doing live streaming, live demos. So hopefully Nelson will be right back.
Yeah, can you hear me?
But yep, we can hear you. You should be back in and hopefully seeing you in just a second.
Webcam is there.
There we go.
Okay.
So let's, I've made you the moderator now. You should be able to present your slides.
Okie doke.
There we go.
Well then,
All you.
let's get started. My name is Nelson Osacky, and I will be presenting about scaling your Android build with Gradle. So a little bit of background about me. I've been previously an Android engineer. I've worked at several different companies, from large projects such as SoundCloud and Square to very tiny startups. So I've seen all kinds of Android builds. I've seen a lot of different patterns, different styles, different strategies, and I'm here to talk about some of those today. And right now I'm a solutions engineer at Gradle. So what that means is I'll talk about that in a sec, what exactly my role is. But some more background, I'm also maintain a couple of Gradle plugins. The first is called Fladle, and what it lets you do is easily scale your instrumentation tests on Firebase. Second is Delect, which easily replaces Dagger with Dagger Reflect to improve your build speeds. And the last one is called Gradle Doctor, and it gives you actionable insights for your build. Cool. So yes, right now I just started working at Gradle as a solutions engineer. What that means is I help our customers improve their Android builds and get onboarded to our enterprise product called Gradle Enterprise, which gives you insights into builds. But that's not what it is what I'm here to talk about. But before we get started, I just want to clarify that Gradle is a company. We build the Gradle build tool. We also build and that's an open source project. And then we also have a Gradle Enterprise product, which helps large projects scale up their scale up their Gradle builds. That's just to give a distinction, because there's a lot of different companies we coordinate with, such as Google. Google builds the Android Gradle plugin and Android Studio. And there's also JetBrains, who builds IntelliJ and Kotlin. So we all work together to improve performance and make your builds more reliable every day. But I just to separate, there's a lot of different companies, and it's not always so clear what part of what product goes with which thing. So since I've been an Android developer, I know what it's like. You always have feature development and you have tech debt. Obviously, there's other things too. There's discussions, there's product research, all kinds of stuff. But in general, you can either work on feature development or tech debt. And I'm going to make the argument that if you're going to work on tech debt, there's refactoring and there's build speeds. But I'm going to say build speed is tech debt, but it always pays off, because you're always going to build the build again, and if you make it faster, you're going to pay off that tech debt that you just saved. So you make your build faster, that's making your work in the future faster. Whereas sometimes you get caught up in these refactoring projects, migrating databases. It's happened to me before. You migrate a database, but then you never use the database ever again. So did that tech debt pay off? Well, I mean, it was fun. I learned something, but at the end of the day, when you're working on build speeds, you're always going to build the project again, unless your whole app gets canceled. So just to talk a little bit about the cost of builds, this is something that I stole from another slide from another Gradle presentation by Cedric. But if you have 60 seconds of waste in your build and you have 50 builds per day, which is pretty typical for an Android project, and you multiply that by 50 developers. So 60 seconds of wasted build, theoretical performance improvements in a build that exists, 50 builds per day and 50 developers, that very quickly adds up, and I don't think sometimes it's hard to realize, but that's 42 hours lost per day, which if you're working a 40-hour week, that means you're losing one developer work week per day. So, and that doesn't even include lost focus, right? So fast builds really matter. You could hire 5 new people without paying them, no recruiting, the cost of onboarding, all that. So what I'm here to argue is that build speed is tech debt. It always pays off. And it's also easy to justify working on it because the numbers are very clear. So now that I have you motivated to work on build speeds, where to begin? This is always the question, right? My build is slow. What do I do? What do I look at? So the first thing I say is update all the things because we have a lot of teams here working on a lot of things to make your builds faster. And so simply by updating, you're going to get a lot of performance improvements. So as of this talk, the latest Gradle version is 6.5. The latest Android Gradle plugin is 4.0. Latest Gradle Enterprise plugin is 3.3.4. Latest Kotlin version is 1.3.72. Third-party plugins, you should also update them. Third-party libraries. But why? Like, what's going on here, right? This isn't like an iPhone where it gets slower every year. I can say that joke because I think you're all Android developers, right? But Android phones get slower every year too, right? So Gradle 6.5, for example, has new performance APIs that plugin developers can use to make the build faster. I'm just quickly giving, like, all these plugins and things have different sorts of things they improve with every version, but the Android Gradle plugin 4.0 has, caching improvements in 4.0, also task configuration avoidance. I'm just like tossing out some random things. I'm going to go over some other features that Android Gradle plugin 4.0 has to improve your build speeds later. Another really interesting one is Gradle Enterprise plugin 3.3.4. It's the thing that uploads build scans. It now does background build scan upload. So if you update, you won't have to wait for the build scan to upload before you install the app. This is a huge win for Android developers. Kotlin plugin 1.3.72 has compiler performance improvements, new flags to optimize your performance. Third-party Gradle plugins are also important to update because they use the new task configuration avoidance API, which can improve your configuration time. It's also important to upgrade third-party libraries. A lot of times they include improvements to incremental annotation processors. Okay, so you updated everything to the latest. I know it's easy to say just bump the version. Sometimes there's incompatibility issues, but if you really want all the benefits of a faster build, you should update everything. And if you don't know what the latest versions are, because obviously the slide is going to be out of date tomorrow as soon as something is updated, there's a Gradle plugin for that. You apply the Gradle plugin just like that, and you run the Gradle task dependency updates. It does it all for you. It tells you what's out of date, what's not. So I recommend using that Gradle plugin. Okay. Before we get started, I know one thing that I think was really challenging for me in making this talk is, well, one, I can't see all your faces, so I don't know what the experience level is of everybody in the audience. So my goal in this talk is to sort of give some tips that everyone can walk away with and some ideas to improve their build speed from people who aren't so familiar with Gradle all the way to experts. And so in order to do that, there might be some things at the beginning of the talk that, might be beginner stuff, or it might be new to you. So just hang on there. There'll be good stuff coming. Anyways, the Gradle build has a life cycle. And this is really important to know when optimizing Gradle, right? There's different areas you can focus on in a Gradle build. There's the initialization phase, the configuration phase, and then the execution phase. So the initialization phase is where Gradle sets up the environment for the build and then determines which projects will take part in it. This is documented more in the documentation, but this is basically figuring out how many projects you have in your build. The second part is configuration. All your build.gradle files are executed at this point in your entire project. So any piece of code you have in your build.gradle file, this is why if you just write a print line, it'll be executed in the configuration phase of Gradle. And then the last part is the execution phase. This will run the task graph that was computed in the configuration phase in order. So you can focus on different parts of these, mostly the configuration phase and the execution phase if you want performance improvements. And so, yeah, let's get started. Where do we begin? Right. So first, we do some things. We check for red flags. What is a red flag, though? Right. So first one to check is if nothing changes in your build, like if you're not touching any source files, no tasks should execute. No task should compile. Right. So what you can do is if you run assemble debug twice, it says in this case, this build, there's 58 actionable tasks and 58 were up to date. So that's normal, right? But if you do something like that, where you run assemble debug twice, and then 3 tasks are execute, then that's a red flag, right? There's something going on in your build. You didn't change the code. Why are tasks running? So, and yet you should do this check regularly, right? Because plugins can change. You can update your code. When you have lots of people working in the project, things can change, and you don't know really what's going on. So it's always good to check regularly to make sure if you don't change any code, nothing happens. So yeah, when that is the case, what do you do? So if you run this in Android Studio, you get the Android Studio build analyzer. You can also get a Gradle build scan. I'll show you how to do that as well. The Android Studio build analyzer is a brand new tool in Android Studio 4.0. I'm not too familiar with it because it just came out, but I'll show you some insights you can gain from it. And then I'm more familiar with Gradle build scans, and I'll also show you some insights you can gain from Gradle build scans. So in this case, what did this build, what did it rerun? It was this inject Crashlytics mapping field debug task. I just noticed Buil is misspelled. That's kind of funny. Anyways, so what happened here? This task didn't declare its outputs, and therefore it's rerunning. Now, I'm not going to get too deep into like the intricacies of tasks and declaring its outputs, but basically it means the task ran, it did something, but it didn't tell the build what it did. So Gradle has no way of knowing what this task is doing. It doesn't know if it should be cached or not. So if you want a little bit more insights into this problem, you can run a build scan. It's as easy as adding -- scan at the end of your build. There's also a link to the documentation. And in the build scan, you can go to the timeline view. This is the same build I was showing earlier where the 3 tasks ran. And if you go to the timeline view on the left and you filter it by task with success, that just means any task that executed. It'll filter the tasks in the timeline to only show the 3 tasks actually executed in this build. And so further down the page, you see the 3 tasks that executed. In this case, that was the inject Crashlytics mapping field debug task that we just saw. And once again, you see it's up to date because there's no declared outputs. And then there's also the 2 other tasks that ran, desugar debug file dependencies, and then package debug. If something changes about your build, usually the desugar and packaging tasks also have to run. So what can we, another insight to gain on this is like, okay, this task ran, but it's only 5 milliseconds. It's not that big of a deal. It is somewhat of a problem because it is changing things in your build without declaring the output. So that's not good for reproducible builds. I don't want to dive too deep into that issue right now. But another thing to note is that it's not just the task that was executed, but also plugin application can add some time to your build. In this case, it's only 80 milliseconds, so it's not that big of a deal. I mean, of course, we're looking at milliseconds, but maybe in your project, like the same plugin could have different behaviors in different projects. So it's always good to check what it's doing. There's other, crash type plugins. In this case, I just applied Bugsnag to the Signal Android app. The Signal Android app is an open source app. it doesn't have bug snag, but I just applied it just to see what would happen. In this case, 9 tasks run on every single build. Luckily in their documentation, they have a way of disabling that. The Crashlytics, unfortunately, does not have a way of disabling it. And in this build, you can see what exactly the plugin is doing. In this case, it's also adding some time to the configuration phase of the Gradle plugin, and it's creating all these tasks. 86 in this case, even after disabling it. So I don't want to get into this whole perf matters thing of like talking about microseconds and builds. Like these plugins, you know, are just adding milliseconds to the build. It's not that big of a deal, but sometimes you have plugins, like the same plugin in a larger build will take up twice as much time. In this case, 100 milliseconds, right? And there's more tasks in this plugin, 545 tasks. Still not that big of a deal. You know, there's bigger fish to fry. If you look at the configuration phase in this build scan, sorry, we're going back to the build analyzer tool, right? So the build analyzer tool doesn't give too much insights into the configuration phase of Gradle, which is what we're focusing on right now. It does tell you over here that the configuration phase was about 4.5 seconds. But if you want to dive deep into that number, I recommend using build scans. So yeah, going back to red flags, right? If you have 5 projects and your configuration time is over 5 seconds, that's kind of a red flag, right? If before we were looking at microseconds, these plugins are taking microseconds, but 1 second for a plugin, that's a bit much, because that is 1 second added to every single build, no matter what you're doing in that build. And then also here, the bug snag plugin is taking a long time. Once again, I added the bug snag plugin. So, you know, sometimes, so in this case, there's it's a plugin called Witness. It's part of the Signal Android build. This is an open source project. You can take a look at it. And it's adding 800 milliseconds to the configuration time. Of course, you can rewrite the plugin. In this case, we can because we own it. But so yeah, what can we do about it, right? When plugins take a long time, and sometimes we see this in other apps, right? In this case, this plugin is adding 25 seconds to the build. That's really a long time. That's something to fix. So what can you do with these plugins, right? So one thing to test is, okay, let's just comment out the plugin. Sometimes you can just comment out plugins, especially for debug builds, and then rerun the build. In this case, so I disabled both bug snag and the Witness plugin in the Signal Android app, and now the configuration time is half a second. And that's a lot better, right? From 5 seconds to half a second, just by disabling 2 plugins. And that affects every single build. So no matter if you're just running help or whatnot, you're gonna get time savings. And so I guess after looking at a lot of Android builds, I can say, and this is really, really rough, and so I don't want to get a lot of flack, but your configuration time should be roughly 5 seconds per 100 projects if we're looking at Android builds, right? Can be faster, can be slower. You know, you might have your application plugin take up 1 second, but then all your other modules take up 20 milliseconds. That's fine. But you should be looking at roughly 5 seconds per 100 projects. If not, then you're that's a red flag, something to look at, right? So one thing you can do about it, if you don't control the plugins, is you can disable plugins for local developer builds, right? So we're going to talk about a pattern I've used in builds to optimize them. Actually, I learned this pattern at Square. It's called the ng-build pattern. And all it is a Gradle property. It's not a build variant. I know there are suggestions out there to use build variants to create a specialized build to improve for local developer builds. I'll talk about why that's not my method later on in a couple slides. So it's just a Gradle property. You can read about Gradle properties on this documentation. But what you can do basically is you can set this Gradle property, and it's really important to have these performance improvements in your build enabled by default, because when a developer checks out the build, you just want them to be a fast build. So this is a Gradle property. You can define it. in your root project, and then you can use it anywhere else, just like this. And then what you can do is just not apply plugins, right? So you don't apply the Crashlytics plugin, you don't apply the Firebase plugin, and then your local developer build is faster. Simple as that, right? You can apply this to any plugin. And then on CI or locally, when you actually want to run the release build, then you disable eng build. And that's a simple way of doing it. Another way, another thing you can do is you can just add eng build equals false to your Gradle properties, so you can stick this on CI. And that's a very simple way of just disabling plugins for local developer builds. And that's the eng build pattern. That's a hammer you can use in your tool set of improving Gradle builds. I'll get back to this eng build pattern later on with some more tips, but just keep it in the back of your head that this is a thing you can do. And this is really similar to how, you know, the Kotlin plugin has a bunch of compiler flags you can enable. It's the same thing, right? You just enable a Gradle property and then your build does something different. Okay, so another thing to look at red flags in your build is lots of tasks being created. In this case, there's 16,000 tasks being created. A simple way of avoiding this is to use task configuration avoidance. This is a new API in Gradle. The docs tell you exactly how to, what to replace, the way you access tasks with another way. I won't get too deep into that right now, but I wanted to go to my controversial slides. So this is the API implementation. I've seen this debated on many Android teams from my experience, many teams, not just Android. So which one should you use, right? And really, so to understand which one you should use, you should understand what's happening, right? If you have module A, module B, and module C, and module A has a dependency on module B and C, and then module B just has a dependency on C, you can do a little shortcut here, and you can declare that module B has a dependency on module C using API. Now what that means is that module C is automatically added to the class path of module A, right? So if you're doing this pattern, you must always be certain that module C is always consumed together with module B, right? You always use module C when you're consuming module B as well. It's kind of like pairing them together. So it's really a trade-off of convenience versus performance. That's what this is. And so how do we prove that, right? And I don't just want to say, okay, convenience versus performance. I mean, a lot of times it makes sense to use one versus the other. We're all developers, we're lazy, there's shortcuts we can do. But let's take a look at a real world example. So this is the K9 Mail app. It's an open source app. It's an email app. You can find the GitHub repo right there. And it happens to use an API dependency on the in this one specific line. I'll link to the slides later in my talk. You can just click that line. And so what can we do, right? So going back to this tool of using Gradle or flags, in this case, we're just going to use a Gradle property. And in this case, we just call it use implementation. So when this Gradle property is enabled, we use implementation. Otherwise, we use API. This will allow us to run both builds side by side and compare the two, and we can profile it. So I'm going to give a quick intro to the Gradle profiler. The documentation's right there, but basically you write scenarios and then you execute them to compare two builds. So if we make a change using the API dependency, this is what you write in your performance scenario file when you're using the Gradle profiler. And then this is the task we want to run. And in this case, we're going to apply a non-ABI change to this one Java file. So that just means it doesn't affect the ABI of that Java class. It's a simple implementation change. And then we write another scenario. It's we just copy it, except in this case, what we're going to do is we're going to add that Gradle argument to use the implementation. So we have two scenarios here. The only difference is the use impl flag. And if we run the Gradle profiler just like this with the benchmark, what it'll do is it'll stop the daemon, it'll clean your build, it'll run 6 warm-up builds and 10 benchmark builds. It is important to run a lot of builds because Gradle builds aren't so consistent. They kind of, sometimes take more time, sometimes take less time. So when you run the Gradle profiler, then you'll get a report just like this. It's really beautiful. Actually, not really, but you also get a CSV file, so then you can export it to your favorite utility. So these are all the benchmark builds. And you can see that using API dependency in this case takes more time than the implementation dependency. Here you also get the mean and the median, the confidence, whatever. So it's about, this is in milliseconds, it's about 10 seconds for the implementation dependency, and it's about 11 seconds using an API dependency. So about 1.5 seconds of difference, which is about a 15% improvement for this one specific scenario in the K9 Mail app. Why is this though? So you can also use different tools to profile using Gradle profiler, not just build scans, but build scans is the one I'm most familiar with. And it'll give you a nice report like that. You can click the links, and we can do the same filter we were doing before, filter the build scans by success. This is the build scan for the success, build scan for the API dependency. In this case, 14 tasks were successfully ran. And in the implementation dependency, you see that only 7 tasks were ran. Which tasks were ran? So here you can see the whole list of the API dependency. If you go further down in the timeline view on the build scan, and then here's the implementation dependency. Okay. So if we want to take a deeper look at why so many tasks ran in the API implementation, we can take a specific look at just one of them. In this case, compile debug Kotlin task. In this case, you see it tells you why this task ran. And in this case, it's because the class path changed, that the reference to the jar where I made the change changed. So this task has to recompile because it has a dependency on that. If we want to know even more about the difference there, this is an enterprise feature alert. So this is what you can do with Gradle Enterprise. You can capture all the task inputs using a flag in Gradle, and then you can compare 2 builds. And here you see the 28 tasks with differences. And what you find is that for that same Kotlin compile task we were looking at earlier, in build B, it declares a dependency on the library where we made the change, only in build B. Build B in this case was the one that used API. So that's a little bit of insight you can gain with build scan comparisons in Gradle Enterprise. So, and that's just a general thing. If you add unnecessary inputs to tasks, you're going to have more things recompile when you shouldn't. So how do we fix this whole API implementation mess? I have API all over my code. How do I know which ones I can remove? There's a dependency analysis plugin. This is written by Tony Robalik, and this will help determine which API dependencies in your build are unnecessary. You can read the docs, apply it to your project, and check it out. All right. So the next part, I'm actually kind of running short on time, so I'm gonna skip through this whole part. You want to make sure your annotation processors are incremental. You can see this in your build. For room, you can enable a flag, and that'll make it incremental. You have to get past the arguments to the Java compiler or Kotlin compiler. I apologize, I'm going through this really quickly. Another thing to note here is you get a remote cache miss. If you want to know more about those, there's a good blog post I wrote, so I won't go too deep into the details there. But one thing to note is that because you have both a cache miss and room's not incremental by default, although you can fix both those things using the Android cache fix plugin and applying the compiler flag, I like to recommend moving room to its own room or module. And this is a pattern you can apply to annotation processors or plugins or anything that's kind of slow in your build, it's a place to focus on when modularizing. So move that to its own place in your build. This is a cool new feature in the Android Gradle plugin 4.0. You can disable unused features. So what are unused features, right? So let's talk about the cost of generating the build config file. So this is a build, relatively large Android build with 186 projects, and so there's 186 generate build config tasks, and that adds about half a second to the execution phase of this build. But if you look at the avoidance savings, it's saving even more than that. It's about 21 seconds. So, if the build config weren't up to date, it would have spent even more time. And it's also unused, so ProGuard's going to remove it later, so it also adds time to your ProGuard in analyzing the build. And the other thing to note is that build config adds Java sources to your pure Kotlin modules. So if you have a Java, and what to note here is that there's a bit of a performance impact to having mixed sources within a module. If you have Java sources and Kotlin sources within a module, it takes a little bit longer to compile in order to make sure they interop correctly. The other thing is, like, it's just also not a good developer experience, right? You have, when you're typing and you get this autocomplete and you're like, how many build config files are there? The other issue is, like, if you're trying to pick up the version code, this can also lead to bugs. So if you accidentally pick the version code from a library project, which is 1 by default in library modules, then you're going to have a bug. So I recommend, there's also other features you may never heard of, such as the AIDL, which is part of the Android Gradle plugin. And so these features are enabled by default because it makes development easier, right? You can just stick an AIDL file in your build and it compiles automatically. You don't need to add anything to your Gradle configuration. And that's really great when you're just starting out. But if you have 186 modules in your app, you want to disable these features. And it also, this is the Kotlin plugin. It also eagerly creates these tasks. So anyways, there's a new feature in Android Gradle plugin 4.0. You can disable these features by default in your Gradle.properties file. I recommend disabling them all. And then what you can do is just enable them when you need them. So what you can do is do Android in any build.gradle file. So for example, your app build.gradle file, you enable build config generation there where you need it. Okay, so this last part of this talk, I'm getting really close to the end of this, is about code multipliers, right? Things in your build that multiply the amount of time needed to compile. The first one is Jetifier. It migrates support dependent libraries to rely on Android X packages. What that means is it runs a transform. If you have this flag in your Gradle.properties, you're running a transform on every single dependency. So if you see this in your build, it doesn't appear in build scans, but if you upgrade your Gradle version, if you upgrade your Android Gradle version, you update your build source, you're going to run all these transforms again. So if you don't need it, I recommend disabling it, of course, but it's a little bit trickier than that. Lots of projects out there. There's all sorts of different constraints. There's also a small bug with dependency substitution in Android X, which will be fixed in a future release. There's an issue tracking that there. I don't have time to explain all the details of that, but the issue is very interesting. If you use dependency substitution, it's a gotcha to watch out for. So if you're stuck on the Jetifier, you should push the libraries you depend on to update, of course. But one thing you can do is you can use this Gradle plugin, Can I Drop the Jetifier? You run that task and it'll tell you what dependencies in your project still need to be Jetified. Another thing you can do is you can Jetify at home. If you just have one library that isn't Jetified in your project, just run the Jetifier on it and upload it to your Nexus and be done with it. That's my recommendation. Of course, from a security perspective, you might not be able to verify the checksums or use dependency verification on this, just something to note. But it might be a build speed win if you just have one dependency left or a couple that need to be Jetified. The next code multiplier we want to talk about is build flavors. This is, I think, something that comes up in every talk. and specifically flavor explosion. So what is flavor explosion? I didn't know, so I went to Urban Dictionary. Flavor explosion is when you drink something that is not what you thought it was, causing a surprising surprise. So what is the surprising surprise in an Android build? It's when you add a build dimension, multiplying build speed in a surprising surprise. So what exactly is that? Every build type you have, for example, debug and release, is multiplied by build flavor, let's say free and paid and Play Store, Amazon Store, whatever, and that's your build variance. And build variants are code multipliers because every single, so if you have most of your app in this module with all these build variants, that means that all that code needs to be compiled that many times. So if you have 6 variants, that means all the code in that module needs to run 6 times. 6 times as many tests are going to be configured in the configuration of your project. All the resources you have in that PNGs, whatever, they're going to use 6 times the amount of cache in your project. So what can you do about this? One thing you can do very simply is you can define a Gradle property. This is, this pattern I talked about earlier. You can just enable only one variant for debug builds by default. So if you have a lot of flavors, and this happens sometimes in builds for various reasons, you can just disable the variants you don't need, very simply. And then if you actually do need a variant, so for example on CI, or you need to check out the other variant, you can just enable a Gradle property to actually build that variant. Once again, it's important to run the Gradle profiler to actually see that this makes a difference, right? On some builds, this might make only 10 millisecond difference. In that case, it's not worth adding this extra hassle of disabling other variants. But in some builds, might be tons of flavors, and this might actually save a ton of time. So it's important to, not just take my advice, run the Gradle profiler and verify it. So yeah, once again, this is mostly configuration time win, but if you have flavors that you never ever use, you should definitely disable them. So this next one is how to cut build times in half. It's not actually how to cut build times in half, but it's very, very similar to the previous slide. So for all your library projects, right, you have the debug and the release variant. Assemble debug, assemble release. That means 2 times the code, just like I said before, 2 times the resources, 2 times the test, 2 times the tests. 2 times the test, that's also another thing to note, right? So the question to ask here is how often in your build does the debug and the release code differ for all your library modules? Like if you have 100 modules, how many of those actually have different code in the debug and the release variants? It's usually like maybe 1, maybe 2, usually not that many. So why would you build all the code twice for all those modules? Even if you're not, you're only using the debug variant locally, you still need to build it twice on CI. That adds CI build times. It also gets a little bit confusing if you run, if you run the normal Gradle lifecycle test task, runs all your tests twice. That's kind of a time waster. And if you run test debug, that's not going to run. If you have Java only modules, it's not going to run those tests. And then what's also really annoying is if you switch, sometimes you do need to test the release variant and you switch to it and then you have to recompile everything. And like I said before, you see it takes twice as long. So what can we do about it, right? So what I was talking about earlier, the eng build, you can use the variant filter we were talking about before. If the variant is release and your library modules, you ignore it. So this will never build the release variant. But there's actually something you can do that's even a little bit better than this, which is disable the debug variant. Always use the release variant. And if you also disable the build config generation, the debug and the release variant are going to be exactly the same. And in that case, you don't need to only do this on eng build, just do it for all the builds, all CI builds, all local builds, every single build in your project, just disable the debug variant for library projects. And then one thing you'll have to do is, for your application module, you can just add the matching fallbacks to the application module. That way, you'll just pick all the release variants of all your libraries. And just like that, your build times will be cut in half. And the other benefit is, when you do need to test the release build, you don't have to recompile everything. So I guess what the lesson here is, disable stuff, right? Use Gradle properties, find out what you can disable. There's a lot of stuff running. Disable it and measure it. One thing you can do is to measure is configuration time. So I went ahead and I did a performance analysis of some of the things I talked about today. I ran a build. The standard build is at the bottom. Everything's enabled. The one at the top, I disabled the debug variant of all the library modules. The one in the middle, I disabled the debug variant and the Android Gradle plugin features that weren't needed. And this is run on the K9 Mail app. And what you can see is this is just the configuration time. So it's not compile time, nothing like that. Unfortunately, it's a really long time to run profiling for all these builds. Okay, so yeah, you can see that this is about 13% faster, 13% configuration time improvement, and this scales to all your builds. So if you have a way longer build, I just got word that I need to wrap up, so I'm gonna run through these slides. So yeah, you can see this is the regular build, the 500 tasks configured, and then when you're debug mode, there's the Android Gradle. Yeah, you can see a lot less tasks are configured. There's more things you can disable. There's a new APIs in the Android Gradle plugin. Here's a link to it. Some other ideas you can do in Eng build is have a higher min SDK. This disables multi-dexing. It disables core library desugaring. Other things you can do is strip out other languages, strip out large images, strip out native libraries so you don't have to compile those, try out new versions of AGP. These are just ideas you can add to your own Eng build to make your build faster. The other thing is always measure. So I just want to give a sneak peek of upcoming performance enhancements before I let you all go. First one is file system watching. This is an upcoming experimental feature in Gradle 6.5. What this does is if you have a build with long snapshotting in task inputs time, such as this build where it's 6 minutes, that'll drastically reduce that time by watching the file system. You can enable it with this flag. There's a blog post about it that talks more about it. The next one is configuration caching. So if you have a build with a long configuration time, your build has to execute all the tasks for all the project. So what you can do is, well, upcoming in Gradle, we're working on a feature to cache the configuration. So this will mean you don't have to do configuration time. I'm gonna skip this part of the build. This is talking about how configuration caching works. Okay, some other talks, some other resources if you're interested is this talk by Cedric Champeau. This was about 2 years ago, but Android builds, the same basic principles of improving Android builds haven't changed much. I actually stole some slides from this talk. There's also a really good talk by at Google I/O 2019 on scaling on different features and Gradle features you can use in scaling your build for large projects. I've also got to plug my own talk. This talks about certain build performance improvements that you'll get by like sharing the Gradle daemon or talking about garbage collection time, things like that. You can also measure the remote build cache performance. I have a blog post there. These are just some resources, blah, blah. Okay, I got to wrap it up. I think I'm way over time. I really apologize for that. So now I'm going to get started on questions.
Yep.
And then also right down there's a speaker deck link to this talk. So just type that in your browser and then you can get, all the slides. I apologize for taking so much time.
No, Nelson, it was great. We want to encourage everyone to just stick around really quick because we've got a great panel discussion coming up. This is definitely something that you're going to stick around for, talking with a lot of very, very knowledgeable and experienced Android experts with scaling up Android builds, asking them all the questions you wanted to know about build performance, static analysis, prioritizing performance versus features and more. So there's a lot of cool things upcoming. I do want to give Nelson just a couple minutes to ask some questions, to answer some questions. We did have a number of questions coming up, so I'm going to ask Jan to make sure that he's presenting all the questions that we've had presented in Slido. And as soon as we get through a couple of those, we're going to introduce our panel. So definitely stick around for a little bit and get your questions juiced up here for our panel. So Nelson, take it away. We're going to give you a couple minutes on this, all right? All right, you should be able to see the questions. You want to read that first question on the top there and go?
Oh, wait, should I see it on my screen?
Nope, we just we just had it up,
Okay.
and yeah, there we go. Can you see those now?
Yes. Okay. Is there any information available about how much capped plugin slows down builds and how to improve on these build times, like Dagger and Dagger Hilt? So this is a really good question that comes up a lot. Build scans show how much time is spent with normal Java annotation processors, but they don't show how much time is spent with capped. However, there is a flag you can enable in the capped extension. I think it's show annotation processor times or something like that. And using that, then you can see how much time is spent with these annotation processors. I also talk about this in the talk I linked about the internals of Gradle, and the Gradle Doctor plugin that I built actually measures all the time that capped is spent with Dagger as an annotation processor specifically. So I recommend checking out my talk if you want to know more about that. Okay. What about release build with ProGuard and all obfuscation? It consumes more time than debug build without it. So yeah, you're still gonna have the release build. It's still gonna take a lot of time with all the obfuscation, but you won't have to recompile all the dependent libraries. Also with ProGuard, the improvements to D8 and R8 will, make the ProGuard time a lot faster. There's also things like the number of rounds that ProGuard and D8 and R8 and whatnot are making on your build that you can tweak to improve that time. But yeah. What is a lower bound to expect from Gradle builds when there are actual code changes made? What is fast? That's a hard question to answer. It really depends on the size of your project, how many lines of code are in there, how many developers are working on the project. Well, actually that one doesn't really matter, but just the lines of code. So I can't really give you a good answer, but actually one I can give you is when I was working at SoundCloud, our average build time on local developer machines was 50 seconds on average. So that's, I don't know, that's a fairly large app, and that was the average build speed. Does API versus implementation really matters when using Kotlin? As far as I know, Kotlin doesn't support compile avoidance. That is true. Kotlin does not support compile avoidance. The K9 mail app does use a mix of Kotlin and Java, and so that, but the tasks that were rerun and not rerun and avoided in the sample I gave, those were Kotlin tasks. So it does help with Kotlin. Okay. Yeah. What's another? I think I got this. Oh, does the 5 seconds for 100 projects apply when using build source? Notice my configuration times are 7 seconds total with build source using 5 seconds. Yeah, I would say it probably still applies if your configuration time when using build source is long. That might indicate something else, something being rerun. So there might be something to investigate as well. Run a build scan, check it out, see what's taking a long time.
Yeah.
Like,
Hey,
I guess, is it
Nelson,
actually
I think we've got.
Oh.
So I was going to say, I think these are actually a lot of good questions, and in fact, we've got someone here that I think would be great to get the panel on as well. So why don't we get the panel in here too? So what I'd like to do is invite all of our panelists here to enable their webcams. They should be able to come on, enable your microphones, and let's get the panel going, because I think there's some of these questions that that our panelists have a lot of experience on too. There's some of these questions I think that are very specific to your presentation. But I think we also have a couple of good questions here. So before we dive into the questions, you can see everybody, we've got a fantastic panel lineup here today. Before we get started, I wanted to just let everybody take just a minute to introduce themselves, where they're working, what they're working on, and to get an idea, because again, this thing is all about build speeds, about performance, the scalability. Obviously, you know that Israel and Yvonne, John, Zach, we're not talking about people just working on backyard garage projects. We're talking about people with a lot of experience working on some major projects. So I think they've got some good perspective here. So let's start with Zach. Really, I'm just going to go from left to right on my screen. Zach, if you want to start, then John, Israel, then Ivan. Talk a little bit about what you do, how many repos you're working in, and also the fun debate that always pops up. We can talk about later too a little bit versus sort of the mono repo versus multi-repo. There's a couple other questions I'd love to ask you all, but let's get started with that. So Zach, why don't we get you going?
Oh, can everyone hear me okay?
We can. Yep.
Hi, I'm Zach Sweers. I work at Slack in our New York office. Prior to Slack, I was at Uber and Flipboard. So you're going to see me around from there. Some bit about our setup. We have really just one repo and only one app that we maintain. So it's a sort of simpler setup. We have about 30 Android developers working in it, give or take. So, yeah.
Great. John, far away.
John, you're muted.
Okay, John, we should be able to hear you now.
Trying that again. Hello, everyone. My name is John Rodriguez, and I work at Square on the Cash App product, previously on the point of sale product, but doing Android things and contributing in a few of the Square open source repos as well. A quick search in terminal tells me that Cash App has 261 Gradle modules, and we are concernedly trying to modularize further. Point of sale, I believe, has reached in the thousands of modules, if not the high hundreds. When I left, it was around like 400 modules. So that gives you kind of a scope of like the size of projects that I've dabbled in. I've played around with like Gradle plugins as well, and I've given a couple of talks on the Android Gradle plugin. So lots of good questions coming in. It's, you know, as people try to increase their speeds.
Gotcha. Israel.
Try to mute myself. Hey, hello everyone. My name is Israel Ferrer Camacho, and I work at Dropbox in the mobile team, doing Android mostly, in the New York office too. And we have a mono repo for all the platforms, and we have over 300 modules there for Android. But the iOS application is there too. And yeah, we are using Gradle for Android and back for iOS.
Great. Ivan?
Hi, everyone. My name is Ivan Gavrilovic, and I'm an engineer on the Android Gradle plugin. Our setup is, I think, when I checked, around like 100 projects that we have that are related to the Android Gradle plugin and some other libraries that are used by the Android Studio. Part of the build is in Gradle, and part of the build is actually in Bazel because of some internal requirements that we had when it comes to building the actual IDE. Yeah, that's about it.
Okay, good. There were one of the reasons I wanted to get the panel involved is because we saw some of the questions coming in I thought were really applicable to the panel. If you know, we're going to click through some of these. Are there anything that you guys are seeing on here that you'd like to address quickly before we get into some other questions? I'm happy to kind of cherry pick some of these questions here. Anything that you see on here that you guys want to answer collectively?
Can I put Ivan on the spot for that original capped question a bit, just since he's worked on it quite a bit?
Yeah, I think that one was interesting. So it was, I think, the first question that showed up on Slido. The question was, what is the impact of KPT on build speed? So when you're using Dagger or Hilt, that's a good question. And before that, I think I need to explain just a tiny bit how KPT works. So whenever you're running KPT, basically there are two tasks that matter in your build. The first one is the one that generates Java stubs from the Kotlin sources, and the other one actually runs annotation processing. So the first one is basically a lightweight coupling compilation. So the compiler front end runs, it resolves all the types, and then it just generates the Java stuff. So you can think of it like in terms of the duration, it's like fairly comparable to actual coupling compilation, the one that's actually generating the full class files. After that, the KPT task is essentially just a wrapper around Java annotation processing APIs. KPT is literally just invoking JDK compiler APIs and just passing all the processors and all the setup that you may have put in your build file and just invoking annotation processing there. Now, when it comes to the build speed and the impact, so coupling compilation supports incremental processing. So, when you have a change in the project, the stub generation is pretty much, it should be able to run incrementally. So from that point of view, it shouldn't be too long. Now, one of the issues was that before KPT was supporting incremental annotation processing, you would essentially rerun all of the annotation processors. You would need to reprocess all of the sources, which in apps that have lots of sources, it is actually quite costly. However, like if you're using annotation processors that do support incremental annotation processing, I think you should not see a big impact there. And Dagger does support it, I think from 2.18, if I remember correctly. I think it's been enabled by default. So yeah, give it a go. I'd say definitely try it out and see what is the impact on your build.
Great. I saw a couple of questions that I wanted to give just small addendum to Nelson's great feedback. One was on obfuscation in R8. We run that only on our CI builds. It's important to run them, and sometimes it has shown some inadvertent runtime crashes, like for example, for using JSON parsers like JSON or Mashi, maybe we've misconfigured something. And also during espresso tests, because currently the test APK, what's bundled into the test APK is unable to necessarily do the tree walk of references that would otherwise be comprised in your main APK. And there are ways to go around that. I believe Zach wrote a plugin that helps there, and there are some other ways to go about that. But it's really helpful to run the obfuscation. However, to the point behind the question is, it probably doesn't have to be in your local developer build, because it's kind of an 80-20 thing. So if you can run that in CI and maybe have a couple of tests that cover the cases, like launching the app and making sure all the app initialization doesn't crash because R8 might have been a little too aggressive and you may need to tweak some rules, it might be a nice healthy strategy to getting your build times to an acceptable fast level while still not compromising your production app integrity. A second thing there, someone asked what's fast, and the answer given there made a lot of sense of like, well, it depends on your build. One I guess general solution that I see helps a lot is we strive to make in our multi-module project as many, and we're talking from this perspective of Android developers here, as many modules that don't need Android types, parcelable, activity, intent. If you can push that away to like your topmost nodes in your Gradle graph, and like when you're compiling the activity, you don't necessarily have to have intent leaking in all of those modules. And intent is essentially a specialized map. And so if you can pass around a map of data and eventually bundle that later on in the build in the module that has to speak to Android things, you get a lot of benefits from that. First of all, you could eliminate roboelectric from a lot of your tests, which is still a big source of like test run slowness. You can remove just a lot of things from the class path because you don't need Android.jar. You just reap a lot of benefits at exponential scale. And so like, I think from a first pass, if you want to, we've noticed increasing or decreasing build times when we achieve by essentially we graph using GraphViz and using colors what are our Android and pure JVM modules, and basically look to advance the front, pushing Android further to the top. And as we do so, we do see notable impact on build times.
Actually, John, that's a good segue, because you're talking about build times. I'd kind of like to see what the panel's thoughts are on some of the kind of surprising build performance improvements that you guys have made in your apps. What have been some of the things that you've done to increase build times? What's been surprising, or what's worked?
I have a recent one, but first of all, I will say if you don't measure, you don't know that it's happening. And we were aggressively improving the execution time of the build, and we were ignoring the configuration time. And then when we were checking configuration time, we realized that that grew more than what we were saving on execution. I was like, okay, we should start measuring configuration and execution and taking care of both. And pretty much any plugin that you add to your build, it's a hazard, right? And we need to be really careful and be measuring those every single day. So, ideally that's an automated job in the CI, and then we have some alerts, and those alerts will let us know if there is a regression in the speed. And when you do that, when you have that baseline, it's way easier to decrease the build time and stop impacting the team really quick, right? So we had this one plugin, I won't name names, but we had this one plugin that was adding a listener to each configuration of each submodule. And that means the execution time and multiply M listeners per M configurations in each module. And that adds like 30 seconds to our configuration, just that one plugin. So, just a heads up, be careful adding plugins and make sure that you do perform and before and after measurement to see how that impacts your build.
Yeah, I wholeheartedly agree with that. I mean, we have the SQL Delight and Wire plugin that we're using internally in our app, and we're constantly mindful of how changes may inadvertently affect build speeds. So measuring that, either if you're using the Gradle build scan functionality or profiling the file and just catting it out to standard out and diffing it across builds, like you can at least come up with some rudimentary heuristic to show like, hey, I added this plugin, because you want to add plugins, right? You want to reuse open source code that you don't have to otherwise write yourself. But to Israel's point, measure so that you can catch these things as early as possible.
I can tell an interesting story that we ran into, or rather we kind of still run into sometimes. It's a bit of a whack-a-mole game where it's easy for an annotation processor to accidentally become not incremental. Even if it declares itself as incremental, if it doesn't adhere to certain requirements for incremental processing, like attaching a source element for every file that it generates, then it will run non-incrementally. And a common case that we run into this with is with Dagger, where Dagger is sort of maybe a little bit too helpful in the sense that if you like annotate your constructor with add inject, but then don't remember to add the Dagger compiler to your actual annotation processing for that project, if you use that somewhere upstream and the Dagger compiler is running there, it will just see that it doesn't have a corresponding factory generated for it, and it will generate it for you upstream. But now it's generating a file that has no source element in your current compilation set, and that's basically something that I think maybe like once every month or so we have a steady flow of new modules coming in, and this one always comes up as a accidental omission, and it's easy to happen because it's not like it like fails your build if you don't do it, but yeah, that makes a big difference because at the end of the day, it's like our monolithic app module that is now running not incrementally, and that's where like 90% of our code is still. And fixing that takes an incremental build from like a minute 20 seconds down to as low as like 30, depending on what kind of files you're changing.
Mm-hmm.
Yeah, it sounds like either failing faster or having a lint check there to warn people would be a great way to mitigate that.
Yeah, the way that we've solved it basically now is we have we call it just Slack plugin that is a plugin that sort of like helps manage all of our projects. And if you want to add Dagger to a project, we actually don't expose the like raw Dagger dependencies, and instead we have like a little DSL. So it's like Slack, and then inside like features Dagger enabled. and that will do all the appropriate wiring. And it's nice because it also handles like, if you're in an Android project, if you're in a plain Java project versus Kotlin, things like that.
Israel, did you have some comment on that one, or?
Not about that one. I mean, that one is a really good way to handle the problem by Slack. So I forgot to mention that configuration phase on the Gradle Buil is not cacheable as of now. It's coming, but not as of now. So that means that when you add a module, you're impacting every single task that you run on Gradle. So meaning even if you clean, you may be impacting that. So like that's why configuration, measuring configuration is so important.
So let's, actually, I want to follow up on that. And everyone can answer this. What's the criteria that you guys set for introducing a new module in the app, or when do you split an existing module into multiple modules?
I don't know if we have set criteria. I mean, I don't know if every module is the same. Like you have new features should probably begin in its new set of modules. But then you may also at the same time want to refactor bundles of logic that are in the main app module to be reused elsewhere. And those are at least two different strategies of how to modularize. I mean, maybe other people have some good heuristics here.
For us, yeah, I think that policy of like every new feature, the default expectation is that that should probably go in its own module. We are in sort of, as I mentioned earlier, we're in this sort of classic case of we're trying to modularize, but we still have like 90% of the code in the like historic app module. And I don't know that there's as much of a like rule or criteria for moving things as much as like thunderous applause when someone does actually take the time to go move something out. There will be some like, what should go here, what should go there kind of discussion, but in general, I think we've just tried to promote it whenever a good opportunity comes up and not really worry about like bike shedding, like the design of, what goes in different modules.
Yeah,
I think here we need to play a balance on allowing every feature team to create their own modules when they need it. But at the same time, we need to start thinking that for each module we create, there are a bunch of tasks that are created for those modules. So we need to make sure that we are not like Backsnack is going to create one task for each submodule that you create, right? So like we need to make sure that we are not creating like 500 new tasks per module, that there is not a lot of like overweight on creating a module, because then everything in the configuration especially is going to be more expensive. So, we worked on measuring how much each module impacts our build because we are close to 500 and we wanted to be sure that that was not a problem. And I think we were creating like 70 tasks per module. And we were able to, by doing the dev mode or engineering mode that Nelson was recommending, we were able to disable some plugins that then it creates less tasks per module. It's at some point, yes, it's microseconds, but like microseconds per 400, it's less microseconds and they become more seconds, right? So, yeah. So you need to balance the scalability with the flexibility for development.
Yeah.
I think that point about being mindful of the plugins that you add is really important. If you use that dependency analysis plugin that Nelson mentioned in his talk, it actually has some basic detection for certain types of like known slow plugins that you could basically remove because it sees them as unused. Capped is the sort of elephant in the room as usual with that. Capped in general, if you can avoid it, just makes a huge difference. Like even if you're using API and implementation, if you have some downstream dependency where it's coming through as an implementation dependency from something else, even if you change that, the class path still changes for Capped, and Capped reruns all of its stuff again. So it's it's worth doing like a one-time audit, I think, using that analysis plugin just to see, if nothing else, at least removing the unused ones. It'll make a bunch of recommendations for other things you can do that are going to be more involved the first time you run it. But I've found it to be really useful.
I see a question here about why disable debug versus release. Does it make any difference? I think the answer is more philosophical. What our team does is we disable debug because release would impact our customers. That's what they would actually see. Debug will have a lot of developer settings, which if something were to break, we are enabled to fix it very quickly. But if we ship something to production, the feedback loop of making that fix, propagating it through the Play Store, and ensuring that it's QA'd is just a longer feedback loop. So we really want to avoid having release broken more sensitively than if we just break ourselves and we send a PR to fix it. So again, it's about our philosophy on that. Maybe there's other philosophies across the panel here.
What we do at Slack that I'm pretty happy with is just all of our libraries are set to be single variant. So the only thing that actually has different flavors is the actual app module, which again, 90% of the code is there anyway, so we're not getting as much of a benefit as we'd like. But at least in terms of like configuration setup, yeah, every library is just set to release. We had a couple of libraries that were relying on being able to have like debug and release variants, but you can also just split those up into 3 smaller artifacts with like an API, a release version, and a debug version. We do this for like Flipper, for instance, which is like a debugging tool where in the production app, we provide a no-op version of it, and in debug builds, we have the actual implementation of it. And those are easy to control with debug implementation versus release implementation.
Yeah, I think. Go ahead, Nelson.
I just want to add, when looking at these flavors, it's just important to be mindful of where you put them and how you're using it. There's a lot of apps where the structure of your code, if you need the flavor just to change the app icon for a different market, then it might make sense to just have a build flag that'll change the icon instead of recompiling your code twice to have a different flavor. So it's just important to be mindful of the tools you're using, because if you add a build flavor that's all your code is twice, all your everything is multiplied. So just make sure that the tool you're using is what you want to happen. And of course, in really small projects, it doesn't matter that much to have all these build flavors, but as you start to scale up, to Slack or Square or Dropbox size, then it starts to matter.
I saw a question that I don't know where it went, but it was about KT-lint formatting, and I think a few of us were actually interested in touching on that one.
Charlie, go ahead.
Yeah, so the question was around KT-lint format from the KT-lint Gradle plugin. It takes a long time because it has to run configuration for everything. And I was going to say that our solution for that is that we just don't use it. We use it for checks on CI, but for actual formatting, we just set up a commit hook and check in the KT-lint jar directly, and it just runs that during the commit hook. So you don't have to pay the cost of doing Gradle configuration every time. We started with Gradle configuration, and then people were like, "Hey, why are my Git commits taking 2 minutes? I don't understand." And that's worked pretty well for us. We do sort of the same with detect, not for formatting, but just running a subset of detect checks on every commit hook, like the most common and quickest ones. And so I don't have numbers to back this up, but before, one of the CI checks that people get hit by most often was KT-lint format failed or detect failed, and now those are almost never failing checks that people run into anymore.
Yeah, I think any static analysis tool that you want to run, you don't really want to run it while compiling. So move it at the last point in the chain when you really need it. So you need it for the code review, you need it to merge it in master, right? So as Zach said, we move it to the Git commit hook. Yeah, the same.
I think here, I just want to second what Zach said. Basically, we have a setup in which we are not specifically using KD-lint, but we're using Google Java Formatter, which I find it's like super great because it gives you deterministic output always, and it's great to have that kind of formatting tool. And basically what we do is it's an upload hook. We are using a repo, it's an AOSP tool for managing multiple Git repositories. But basically, whenever you want to push something, some CL, we run these checks. And just to add one thing when it comes to static code analysis, I think like one thing that is sometimes like missed in the discussion is also just relying on the IDE and lint in the IDE to do the right thing. I think like it's super helpful that like while you're working on the code, just you can fix it straight away. So it's not necessary that you have to run this, from scratch kind of thing. You can just rely on the IDE, providing you with suggestions as you write code.
Yeah, on that note, this is a bit of a touchy topic, but like Android lint, for example, we've written custom lint checks, and they constantly need maintaining when a new version of the Android Gradle plugin comes out, and sometimes like breaks our CI. Like right now, our slowest running shards on CI, including the espresso test shard, are the lint shards. And we're actually considering disabling it on CI, which we don't want to do for obvious reasons. Like then we're kind of flying blind on some things, but I know like there's been mention of this in some of the Google groups where it would be really nice maybe to get some roadmap there to hopefully make that a little more extensible.
Feedback noted.
Yeah, lint checks.
Oh, sorry, go ahead.
I was going to say lint checks, the more that you can reduce, we'll say, developer cycles of like going to CI and then lint failing and then them coming back to fix it and then going back again, the better. Just because, yeah, it's sort of by design. Lint gets a little bit slower every update. With AGP4, it got a lot slower. We're still trying to figure out why. So it's really powerful for, you're never going to find a more apt spot to inform people about lint issues than in their IDE and where their code is.
Yep.
So leaning on that it's been nice for us at least.
And talking about under lean on the IDE, I encountered that makes especially coding files a little bit slower to edit because I think there is some issues I actually reported, but like that's why I have them disabled on the IDE and I rely on the.
I don't know if all those are lints or some of those might be IntelliJ inspections, but whenever I'm waiting for the eye in the upper right of my IDE to hover and I see slow inspections doing that slow counter, I just get a coffee.
I have those disabled too. It's pretty much been for me now at this point.
There's some known issues in the Kotlin plugin itself, like the IntelliJ plugin that they exist on UTrack. You can follow along with them there. Yeah, I think my favorite one right now is optimizing imports will take like 15 seconds on like a trivial file, which is sort of alarming. But anyways, we should get back to the questions.
There was a follow-up there from somebody. I'm just going to read it here. When modularizing, how strict are you when deciding and enforcing whether or not a module has an Android plugin enabled library app or whether it should be Kotlin only? I'm not sure this is a direct follow-up, but it was just came in, and I thought it would kind of keep that discussion going.
Sure. Please.
I was going to say, we don't have like a set policy on it. I would say that probably the default right now for like historical reasons is to just make it an Android project. J-Rod mentioned this earlier, that like if you can just make it a plain old Java or plain old Kotlin project, then it is going to be faster by virtue of having less overhead. So that's something that we want to try to explore doing with the help of the dependency analysis plugin in the future. Basically detecting like, could this project be a plain JVM project, and if it's not using anything from Android. But
A member of our team, Benoit, just wrote a blog post on this. It describes our architecture, and it's opinionated. Everyone has their own architecture, but ours tends to be where we have some concept of a presenter controller that is Android unaware. It is a completely JVM, and so the idea is that that presenter contains all of your business logic, and whether it's rendering that to an ASCII terminal, an iOS platform because you're using Kotlin multi-platform, or an Android device, it is unaware. And then that can be a JVM Kotlin module. And then you would probably have an analogous views module. We are single activity. That's another opinionated architecture that we use. And because we're single activity, all our activities are really in that kind of app hairball module. And then we'll delegate all our feature specific views, you know, the cash card views, the boost views, those will all be in a views Android library module. And so that makes sense, right? You need context, you need resources, you need fonts, etc. So that would all live there. And then, so then the boundary conditions there are going to be like, how do you represent something that is font-like or image-like? Well, so we use Kotlin sealed classes and like an icon class. And like if we have, let's say the icon has 3 different modes, we'll have 3 different values in that sealed class, and we propagate that from the presenter to the view. Internally to the view will then map that to say a Picasso, you know, image renderer or, you know, what have you. So that's keeping the Android boundaries only within the view, and then just creating some lightweight mapping layer will allow you to kind of push more now of the Android platform out of your build modules. So that's how you achieve that goal, or one way to achieve it.
Excellent. We spent a lot of time earlier in the discussion talking a little bit about, a lot about plugins, in fact, featured plugins, and I think this is something that maybe Ivan and Nelson could maybe talk a little bit about. I know it's a little bit departure from what we were just talking about, but talking about what are some of the kind of the issues that your teams, Google and Gradle, are seeing with sort of community plugins and projects today. Love to kind of get your take on that.
Yeah, it's a good one. I mean, I'd say that when talking about the plugins that you apply to your build, I'd like to see more people thinking about them in the same way that you're thinking when you're adding a library to your application, right? Like you would do some sort of audit there, figure out, you know, what's the quality, does what it says it does, and just apply some level of scrutiny there, like when actually adding something to your build that may impact the build performance ultimately. So, and I think that's on the folks, you know, I would say that's responsibility of the folks who are maintaining the build in their companies, or like if there's none, I guess all the engineers. So some of the issues that we're seeing is, I'd say like on the AGP side, we were not as good when it comes to talking about our APIs and how people should use those APIs. And that has led to lots of confusion, people sort of scrambling just to do their thing. And that is something that we're trying to address in 4.1. Actually, there's like a subset of the new APIs that we're working on, and 4.2 should have the finished version of those APIs, allowing plugin authors to customize their Android part of the build in a reliable way and in a way that does not impact the build. I'd say that's like on our side, but I would also say that I think the documentation on the Gradle side, while it's pretty good for some things, I'd say like when it comes to plugin authors, I think it could be more opinionated and more like tutorial based, and just like to tell people how exactly to do things. And to be fair, like things have been changing quite a lot recently, and I think there's lots of improvements there. Like the one that comes to mind immediately, like we are running all of our builds, there's like a flag -- warning mode, and like we're running all of our tests with -- warning mode equals fail. What this means is basically Gradle runs some checks dynamically, and then if it detects that you're doing something that you shouldn't, it's just gonna break, right? And that's how we catch lots of issues on our end. I mean, we also, you know, introduce bugs. So, you know, I think that helps a lot. And also, I'd say for the plugin authors, just like keeping up to date with all of the new stuff, it can be a bit overwhelming. But I think, for instance, when it comes to configuration caching, the new stuff that should be like in 6.6 of Gradle, I think that's really worth the investment. And I think for the plugin authors, I think it's for all the users of their plugins, it's going to be a huge benefit if all of the plugins are actually compatible with configuration caching, because it's going to impact build like positively quite a lot.
You're saying we shouldn't use the internal packages that we see?
Oh, dot internal, like, yeah.
Yeah, those are really good points. I just wanted to add a little bit to that. I think as a plugin author, it's definitely really difficult to keep up with all the new API changes that are happening, like lazy or task configuration avoidance, like property providers, configuration caching, like all these things. And a lot of times plugins want to maintain some backward compatibility to be compatible with larger projects. So it sometimes is a difficult choice for plugin maintainers. Like, do they want to just do nothing and support larger projects, or update to the new APIs and use the performance of those APIs? One of the things my team actually does right now at Gradle is when we see one of these issues with some of our larger customers, we actually try and fix it in the open source library. So Daz, for example, on my team worked on the Spotless plugin, actually is currently working on the Spotless plugin to make it incremental. Some of the things is, you know, if you're just working on a plugin, you're probably using it on your small project, but sometimes people take this small plugin and apply it to like a massive project, and then it has scaling problems, and we just have to work and fix those scaling problems. Yeah, so task configuration avoidance is one. Another one my team sees is, this is more for larger projects too, but remote cache misses. So when some task input to your task is not compatible with your remote build cache. One example is using absolute paths as an input. And this is something that I think it's really hard to test for, and most Gradle plugin authors are completely blind to, because, well, you're only testing it on your local machine. So that's another one that my team helps out with. And we also have one for the Android Gradle plugin. Another one I just want to note is, please file bugs for all these things, whether it's a plugin, you know, you see performance issue with it. Doesn't matter if it's with Gradle, if it's with the plugin, with Android Gradle plugin, like the feedback is really valuable to use to improve, like how many people are having that issue, and things like that.
So one question that I often get from people when I give similar feedback is, how do I, if I can't come up with a sample repro, or if I can't determine whether it's Gradle, Kotlin, or AGP's fault, how do I do that? Do you have any maybe advice on that? Because that could probably be part of the barrier to getting those issues filed, is now you file on all the issue trackers and the authors are like, oh, this isn't our problem, it's this problem. It can be a little hard to be motivated to do that.
Yeah, that's a really hard one. That's why I have the slides at the beginning where it's like, all right, there's JetBrains, there's Google, there's Gradle. Honestly, I don't think I have a good answer for that. I'm not going to try and bullshit anything.
I think what we did recently was we found an issue on a plugin, and we just got like 2 build scans, one with and one without the plugin, and then we did a little bit, you know, we read the code and see, oh, I think this is the problem, and then we remove the line, and it was obvious that was the problem. But I guess at that point you are just submitting the fix. I know, but I guess we want to know, as owners of an application, if the plugin is the problem or not, because if the reason that we have the plugin is because it gives us some features, right? So I think that's something we have to deal. But like A/B performance measurement should, you know, enable and disable the plugin should be obvious if it's like a big issue, right? So yeah,
I think
not a
with
go
ahead.
Just to add something here, like I'd say, like definitely please do file bugs. Like I'd say it's even better to file bug in the wrong the wrong company at the wrong component rather than just staying quiet, right? I mean, what I try to do and what my team tries to do is like we see some report, a bug report, and then we will try to figure out whether it's issue in the maybe IDE, whether it's in the Kotlin compiler, whether it's Gradle or some other third-party plugin. But at the same time, I'd say please try to add some data to it, like does the describing this doesn't work full stop and creating a bug is good, but like it's we're not that many action items on our end. So just try to add some data, and then someone will hopefully help you to direct you to to the right issue tracker if you got it wrong.
Yeah, the thing I was going to say related to that is basically it's better to file with like limited data than to not have it filed anywhere at all, especially because once you have it filed somewhere, if someone else runs into the same issue, they can then chime in on it with perhaps more context on it that makes it easier to sort of start seeing what the similarities are. And also just make sure that you're making it known that you can like help them test stuff. So if I'm like, hey, like I don't really know how to like put this into a reproducible sample. It only happens in our giant monolithic app. But if there's anything I can try, let me know. And that back and forth is usually really helpful. And I think not always, you would think that it's like implied or implicit, but I think that it's important to also just drop it in there as an option. Should we try to burn down some of these questions? Oh,
yeah, I think that's a good idea.
Yeah, I was going to say we depending, I don't know how much time you guys have to stay with us, because we can keep these questions archived and send those on to Nelson. We've got a handful of these, but I think we are pushing up a little bit against our time limit here for the panel. So maybe Nelson, if you're okay, what we'll do is archive these questions and push those out to you to get back to some people on.
Yeah, I guess I'll follow up with you on how to get the answers to the right people.
Okay, yeah, we'll do that. We'll kind of figure out a way to post those. I did want to just kind of ask one kind of final question on our way out here. I want to look sort of forward here and talk a little bit about some of the features, some of the changes that build maintainers should be prepared for in the future. What's kind of some of the things that it might be a little bit for Nelson and Ivan, but want to talk a little bit about looking forward here, what people can expect in terms of the features.
I think the biggest one I can see is for sure configuration caching in Gradle. It's going to impact everything from your build scripts to plugins you use, Gradle version, Android Gradle, like everything's going to change in order to support this feature. It's really a big effort, and it's a big collaboration too between the Gradle teams, the Google team, and the JetBrains team. But it's gonna make for a lot faster build, so that would be the thing to watch out for, I would say.
Yeah, I would just add the thing that I think I already mentioned. It's the new APIs that we're working on the Android Gradle plugin. So while we are not going to remove the old ones, we're going to start deprecating them, and we're going to provide migration tutorials for folks to start using the new ones.
Sure. Another thing that I drop in, and Elon, correct me if I'm wrong, namespace resources should be available in AGP 4.1, I think, and that one basically would be a pretty big win for avoiding that merge resources task, especially if you have the giant app module at the top. That's usually one of our longer ones.
Yep. I think we have addressed part of that. Yeah, in 4.1, I think it should be there.
Great. Hey, panel, thanks so much for everyone for being here. Nelson, excellent job on the presentation. A lot of good takeaways there. We did have a lot of questions. I apologize to some of our attendees who we weren't able to get these questions to, but we do have an archive in Slido. and we'll make sure to work with Nelson on making sure we get some questions that were specific to his presentation answered and out to everyone who attended the session. So Zach, John, Israel, Ivan, thanks so much for being here. It was really great having you all with us and get your perspectives. I found it incredibly insightful. It was a lot of fun talking with you all, and we appreciate everyone who was with us today, and everyone who stayed with us. It was actually fantastic to see how many people have stayed to watch this panel. It was really good. Appreciate it. Thanks for being here. We've got a lot of exciting stuff coming up in our webinar series, and so we're happy to happy to have you guys with us again next time. So we'll end our session here and wish you all a great day, good week, and we'll see you next time. Okay.
Cool.
Thanks so much. Bye-bye.
Bye.